Hello students, in this video we will discuss about the concept of maximum work done and derivation for the maximum work done in chemical thermodynamics. So here maximum work done. In the last video we discussed about work done and pressure volume work done. In that case here free expansion of gas or work done in the pre-expansion. So if the expansion of gas is carried out in zero pressure or at zero pressure, that is in a vacuum. So here P external is equal to 0, and as we know that W is equal to minus P external into del V. Here as this P external is equal to 0 and therefore W is equal to 0. So here in vacuum, and this is called as a pre-expansion of the gas. So in vacuum, or in other words, work done in the vacuum is 0. That is, no work done is occur in the vacuum. Okay. After that, here maximum work done, concept for maximum work done. Consider a gas enclosed in a cylinder. That is n numbers of moles of gas enclosed in a cylinder with weightless and frictionless piston. Okay. Now that pressure on the gas, it is P, and if there is no movement, then the pressure on this piston is also P. Okay. If it is moved on upward direction, means for the expansion of the gas, this P pressure on the piston, it is infinitesimally less than that of the pressure of gas. Means driving force is infinitesimally greater than the opposing force. Okay. So now here P external P minus P external, pressure of gas minus external pressure is equal to del P, and therefore here pressure minus P external or pressure on the piston is equal to, that is equal to P minus del P. Okay. This is the pressure on piston and this is the pressure of gas. It is in the form of force, it is the driving pressure, and this is the opposing pressure. And for reversible reaction, here driving pressure is infinitesimally greater than that of the opposing pressure or pressure on the piston, and this is the condition for reversible process. And in that reversible process, work should be maximum or work done is maximum. So the derivation for maximum work done. Now again here a gas is enclosed in this cylinder and the numbers of moles of gas are n with weightless and frictionless piston. Okay. So this is the initial volume V1 and the expansion takes place when the pressure is P minus dP, that is volume of the gas is V2. Means the change in volume from V1 to V2. Okay, this is V1 and this is V2. So according to pressure volume work, this work done is equal to work done, that is dW is equal to, this is equal to P minus P external into change in volume. There is a very change in volume, therefore it is called as a dP. Okay. And the change, that work done dW is equal to minus P external into dP. Here dW is equal to minus P external means P minus dP into dV. This is change in volume. This is dV. Okay. Now put this is W, dW is equal to minus P dV minus plus dP into dV. Okay. So as the change in volume is very small and dP is also very small and the product of two very small quantity, it is very small, that is negligible. And that's why this equation is dW is equal to minus P dV. Okay, so integrate this equation from V1 to V2 and work done from initial to final. Okay, so here integral, this is initial and this is final. Okay, this is dW is equal to minus integral P dV V1 to V2. This is the pressure and it is not a constant because it is variable. P minus del P, P external, and therefore here this is equation number 1. So according to ideal gas equation, PV is equal to nRT, where T is absolute temperature at constant temperature, R is gas constant, N is numbers of mole, V is a volume and P is a pressure. And therefore here P is equal to nRT upon V. Putting this value of pressure in the equation 1. And we get here integral dW is equal to initial to final, that is W max, maximum work done, that is W max is equal to here minus integral V1 to V2. Now P dV, P means nRT upon V into dV. As N is a numbers of mole constant, R is a gas constant, it is and here T for isolated system it is also constant. So here minus nRT integral V1 to V2 dV upon V. Integral dV upon V is ln V, limit V1 to V2. So here upper limit minus lower limit. So here minus nRT ln V2 minus ln V1. Okay. So this is minus nRT ln V2 upon V1. But this is to the base E. The converting factor of log to the base E to the log base to the base 10, that is 2.303, and therefore here minus 2.303 nRT log to the base 10 V2 upon V1. This is W max. But according to Boyle's law, P1 V1 is equal to P2 V2, and therefore here P1 upon P2 is equal to V2 upon V1. Putting this value in this equation and we get W max is equal to minus 2.303 nRT log to the base 10 P1 upon P2. This is expression for maximum work done. Okay. So on the basis of these two expressions, one is pressure volume work and second one that is maximum work done. Then after watching first video, last video and this video, attempt the following questions and solve the following problems. 1. Derive expression for work done in isothermal and reversible process. Or its next one question, that is derive expression for maximum work done. Okay. Next question. 3 moles of an ideal gas expanded isothermally from 15 dm cube to 20 dm cube at constant external pressure of 1.2 bar. Calculate work done in joule. Next question. 22 grams of carbon dioxide compress isothermally and reversibly at 298 Kelvin from pressure of 100 kilopascal when the work is obtained 1.2 kilojoule. Find final pressure of the gas.